Hi guys, I wanted to do some notes on dividing complex numbers. Just to recap a little bit, I did give you this cheat sheet. So you can always take this out and it'll help you with all of the different operations for complex numbers. I have an example of addition and subtraction, multiplication, so breaking up that negative number under the radical into -1 times that number. So that way that I can come out on the outside. I have an example of FOILing with complex numbers. Remember, when you get a I times an I, that's an I squared, which turns into a -1. And last but not least, I wanted to get into the division today. So when you're dividing by imaginary numbers or complex numbers, here's an example of 14 divided by I. You want to get rid of the imaginary number in the denominator, just like you would want to get rid of the radical in the denominator. The way that you do this is by multiplying by I over I. And then multiply straight across. When you do this, for this example, I get 14I, and then I get I squared. I squared we know is -1. And then I can simplify this because 14I divided by -1 is just -14I. So let's do a few examples in your packets from yesterday. So I'm in the 4.6, performing operations with complex numbers. You should have this already. This is what we worked on yesterday. If you don't have it, there's extra copies that the substitute has. I'm going to start with number 13. So I have 3 plus 2i over -5i. I need to simplify this. So I'm going to get rid of the I in the denominator. So I'm going to multiply the bottom and the top by I over I. When I multiply straight across, this I is going to be multiplied to the 3 and to the 2i. I need to distribute this I to what's inside the parentheses. This gives me 3i plus 2i squared over -5i squared. All of our I squareds turn into -1. So this is going to be -1. This is going to be -1. So rewriting this, I get 3i, and then 2 times -1 gives me -2 over -5 times -1 gives me a +5. Now I'm just going to rewrite this equation because we always want our real number out in front before the imaginary number. And there we have it. Next we have 7 plus I over 14i. So I'm going to multiply by I over I. The I gets distributed to both terms in the numerator. So that leaves me with 7i plus I squared over 14i squared. This will simplify to 7i minus 1. That turns into a -1. This also turns into a -1. So -14. I just want to rewrite it so that way the real number is out in front. So I've got -1 plus 7i over -14. For the next one, multiply by I on the top and the bottom. This gives me 20i plus 40i squared all over 100i squared. All the I squares turned into -1s. So 20i minus 40 over -100. If I simplify this down, I could divide by 20 across the board. So this will give me I minus 2 over -40. 5. Rewriting it, I get -2 plus I over -5. For the next one, multiply by I on the top and the bottom. I get 21I over 60I squared. This will give me 21I over -60. Simplifying 21 over -60, I can divide by 3 on the top and the bottom. And I'm going to end up with 7I divided by -20. Last but not least, I'm going to do the same thing here, but first I can simplify the numerator down a little bit by distributing the negative to the 3 and to the -7I. So at the top we'll have 7 plus I minus 3 plus 7I. And I've got some like terms here I can combine. 7 minus 3 is 4. I plus 7I gives me 8I. So now that I simplified the numerator down a little bit, I can multiply by I over I. Another thing I can do is divide by 2 across the board. So if I want to start by doing that first, I absolutely can. So divide every term by 2. So that way I can work with smaller numbers. Okay, and then I can divide by I over I. This I is going to be distributed to the 2 and the 4I, so I'm left with 2I plus 4I squared over 7I squared. This guy turns into a -1. This guy turns into a -1. I'm left with 2I minus 4 over -7. And again, if I want to rewrite it so that way my real number is out in front, I've got -4 plus 2I over -7. All right, so here are your notes for today. What I'm going to have you do is numbers 9, 10, 11, 12. And just as a bonus, see what you can do with 13. Okay, so 9 through 13. After this, you're going to do the Delta Math assignment. Have a good day, guys.